Hi everyone and welcome to today's video. This is a B1 level science lesson and today we're going to be talking about the scientific method. All right, so what is the scientific method and why do we need to use it? So those are some of the questions we'll be answering in today's lesson. So you're going to read the sentences and predict the meaning of the bold words. You can pause the video and read on your own, or you can follow along as I read. After careful observation of the bird, the scientists learned how it built its nest. The scientists designed an experiment to test his hypothesis. The conclusion is that too much water has a negative effect on plant growth, and they had so many participants in the experiment that as a result had much more data than they had expected. All right, so observation just means to look at something, to study it. A hypothesis would be the question or the uh, thing that you're trying to prove or disprove. The conclusion is what you actually find in the experiment, and the data is the information that you collect through your observations. So, scientists analyze data to find patterns or relationships that can help them draw conclusions about the experiment. A good scientific experience starts with a hypothesis, which is then tested through observation and the collection of data and leads to a conclusion. The data collected during the experiment supported the hypothesis, and the scientists' careful observation and analysis of the data led to a new hypothesis, which was then tested with more experimentation to reach a conclusion. All right, so complete some common collocations with data, um, conclusion, or hypothesis. And a collocation is like an expression or a group of words that are used or commonly used together. So, for example, after analyzing the data, we can form a conclusion that the chemical is effective at killing bacteria. So, you can form a hypothesis or a conclusion. You can analyze data. You can reach a conclusion, collect data, draw a conclusion, test a hypothesis, support the hypothesis, and gather data. All right, so there's a series of steps in the scientific method, and can you put them in order? So one, you would ask a question, define the problem. Then you would form a hypothesis, collect data, analyze the data, and draw conclusions. And the steps in the scientific method can be used to answer many questions in everyday life. For example, what is the fastest way to get from my house to the library? What is the most popular lunch option in the cafeteria? And when is the best time to go to the supermarket to avoid lines? Then you create a hypothesis or an educated guess that can be tested. For example, the fastest way to get to the library is Wright Street to State Street and then Park Avenue to Route 2 to Spring Street. And see if you can make a hypothesis for the other questions, the other two questions. Next, you're going to design an experiment to test your hypothesis. So the question, what is the fastest way to get from my house to the library? The hypothesis, the fastest way to get to the library is Wright Street to State Street, then Park Avenue to Spring Street. So the experiment would be maybe to travel um, the route described in the hypothesis at different times of the day, measure how long it takes, and record the data. Then repeat with a different route and compare the results. All right, so now we're going to look at the data. What conclusion can you draw? So they have four different routes, A, B, C, and D. So route A, they started at, it took, they tried each route 3 times. So the first time, route A took 6 minutes and 29 seconds. The second time, it took 6 minutes and 11 seconds. In trial 3, 7 minutes and 42 seconds. And so the average of that was 7 minutes and 7 seconds. And some notes, there are 2 traffic lights on the route, red light on trial 3. So this would kind of explain why trial 3 took longer, because they had to stop for the red light. Route B, 6 minutes and 55 seconds, 7 minutes 49 seconds, 6 minutes 47 seconds for an average of 7 minutes and 30 seconds. 2 traffic lights on the route, and they had to stop for a red light on trial 2. Route C, 6 minutes 59 seconds, 6 minutes 22 seconds, 6 minutes 25 seconds for an average of 6 minutes 35 seconds. There's 1 traffic light on the route, and they had to stop for a red light on trial 1. And then route D, 6 minutes 43 seconds, 6 minutes 32 seconds, 6 minutes 8 seconds, and 7 minutes 7 seconds. And there are no traffic lights on the route. So from the average, it would appear that route C is the fastest route um, based on the average. A and D would be about the same, and B would be the longest or the slowest route. All right, so now you have to identify whether each of these statements is an observation, a hypothesis, or a conclusion. So the temperature outside is 85 degrees. Well, that would be an observation. She would look at the thermometer and determine what the temperature is. If I water this plant every day, it will grow taller. Well, that's a hypothesis, sort of an educated guess. makes sense that that would happen, but we won't know for sure if it happens until we test or do an experiment. Based on the data we collected, we can conclude that the more fertilizer we use, the taller the plants will grow. Well, that's a conclusion because it says it's based on data, so they've already done an experiment, and this is the conclusion they reached. The apple feels smooth and round. That's an observation. If I add sugar to this water, it will dissolve faster. That would be a hypothesis. Our data shows that the more sunlight plants receive, the greener their leaves become. That's a conclusion, again, because it's supported by data. And the dog barks loudly when someone rings the doorbell. That's an observation. So, planning an experiment. There are phrases that are common when you are planning a scientific experiment. So, the biology teacher wants to test the effect of music on plant growth. So, let's try exposing plants to classical music and hip hop music. So, we use let's try, the verb plus the ing. We need to be sure that the plants don't hear the other music. So, need to be sure that plus the subject and then the verb. And what would happen if a plant is exposed to classical music for 1 hour a day? What would happen if plus the subject plus a past tense verb? And I will gather the data in the chart. So, will gather is the future. So read the example experiment and match the word or phrase from the experiment with its definition. You can pause the video and read on your own, or you can follow along as I read. Pretend that you want to investigate how different types of light affect the growth of plants. You set up an experiment in which you grow two groups of plants under different types of light, one group under red light and the other under blue light. The control group is the group of plants that is under normal daylight conditions, no special treatment. The independent variable is the type of light that the plants are under, red or blue. And the dependent variable is the growth of the plant's height, number of leaves, etc. So the variable in an experiment that is changed by the researcher, that would be the independent variable. A group in an experiment that is treated in the same way as the other groups in the experiment, but is not exposed to the independent variable being tested, that's the control group. And the variable in an experiment that is measured or observed, that is the dependent variable. And what is the purpose of the control group? Well, the control group will show whether either of the independent variables make any difference, because if all the plants grew the same, the ones that didn't have any light were the same as the red and blue light, that would show that the red and blue light doesn't make any difference. So the con- um, the control group is there for comparison purposes. And what is the purpose of the independent variable? Well, that's to observe the effects of these different factors. In this case, the different type of light on the test plants. And the dependent variable is just to show the differences between the plants that were selected to the blue light compared to the control group and the ones subjected to the red light as compared to the control group. Okay, so now identify the independent, dependent, and control variables. And first we have some vocabulary. So ice cube, it's a picture of an ice cube, so a noun. Melt is a verb to change from a solid to a liquid. Participant is a person who chooses to be in a study, and heart rate is how fast a heart beats. So you want to investigate how the temperature of water affects the time it takes for an ice cube to melt. You fill 3 cups with water and place an ice cube in each cup. You leave one cup at room temperature. You place another cup in the refrigerator and a third cup in the freezer. S- So here, the cup that is the water that is at room temperature is the control. So the room temperature is the control. The cup in the refrigerator and the freezer, those are the independent variables. And then the amount of time that it takes for each of the ice cubes to melt would be the dependent variable. You want to investigate how different types of music affect a person's heart rate. You find 10 participants and measure their resting heart rate. You then have each participant listen to one of three different types of music, classical, pop, or rock, for 10 minutes and measure their heart rate again. So here, the resting heart rate would be the control. The types of music, classical, pop, or rock, that's the independent variable. And the heart rate after listening would be the dependent variable. So, have you ever participated in a scientific study and do you want to? So, now we're going to read about the experiment and decide which of the following factors must be controlled for the results to be valid. And valid is an adjective meaning to be able to be accepted and seen as the truth. So, a student wants to investigate how the amount of salt added to water affects its boiling point. They set up an experiment in which they heat 2 cups of water on a stove and add different amounts of salt to each cup. They measure the temperature of the salt with a thermometer at the point when it starts to boil and record their results. So we need to decide yes or no whether each of these factors need to be controlled in order for the results to be valid. So the amount of water must be the same in the pots. Well, that would be yes, because a smaller amount of water is probably going to boil faster than a larger amount of water. The temperature of the water must be the same at the start. Well, that would also be yes, because cold water will take longer to boil than hot water. The setting on the stove must be the same. That would be yes. The time of day must be the same. Probably not. And the pot must be metal. No, just both pots would need to be the same, but they don't necessarily need to be metal. All right, and now we're going to look at experiment errors. So read the experiment and what mistake did the student make? So a student wants to investigate how different types of soil affect plant growth. They set up an experiment in which they plant different seeds in three different types of soil: potting soil, sand, and clay, and place them in different areas of the classroom. After 2 weeks, they measure the height of the plants. Well, they use different seeds. So some of the seeds might just naturally grow faster than the other types of plants, depending on, no matter what the type of soil. Um, so that would, I would say, be the biggest mistake. All right, so now choose a topic or create your own to design an experiment. And here we have some vocabulary: memory, the ability to remember things that you have learned or experienced before; reaction time, the amount of time it takes for your body to respond to something like catching a ball or stopping at a red light; whitening, making teeth a white color; hand sanitizer, a gel or liquid that you can put on your hands to kill germs and keep them clean; bacteria, tiny living things that can be found all around us, including on our skin, in the air, and in some foods. So you can choose one of these topics or one of your own, and then answer these questions. What is your question? What is your hypothesis? What is the control variable? What is the independent variable? What is the dependent variable? And what factors need to be controlled so the results are accurate? And that brings us to the end of today's video. Please like, subscribe, share, and if you have any questions, leave those for me in the comments. Thanks for watching. Bye.